Hey everybody, in this video we want to solve problem in 895 maximum frequency stack. This is a problem that we are asked to implement a data structure called freq stack, and this data structure should support two functions, a push and a pop. And push is very simple. Whenever we receive a new value, we just add it to our data structure. But for pop should always return the most frequent element in the stacks. So for example, if we have 3 x's and 2 y's already added to the stack, x is more frequent than y, so we should return x as a return for pop and then remove that. In case of tie for two elements, so for example, if two elements have the same frequency, for example, 3 x's and 3 y's, depending on what element added to the stack more recently, we should return that. Or in other words, the element closest to the stack's top is removed and returned. So we should just remove and return the element that added to our data structure more recently. In these types of problems for implementation, you first should consider what are the functionalities. So in this problem, we should only implement push and pop in the most efficient way, or we should put our effort, the maximum effort, to make these two functions as performant as possible, or the time complexity and space complexity of the data structure should be improved, or minimize the time consumption for these two functions. So there might be other ways to implement this, but what I want to do is to use double layer stacks, or two stacks in 2 layers. The first one, this stack, only handles or stores the secondary stack. So this is a stack 1. At each layer, it has other stacks. So layer 1, layer 2, layer 3, and then each of them has a secondary stacks themselves. And this first layer stack only stores the information about, or stores all elements have a frequency of 1. The second layer stores in a stack all elements has frequency of 2. And the reason behind using a secondary layer stack is because of, in case of tie, we should return the top element. So for example, if we have already 2 elements of the same frequency, let's say 5 and 6, we are about to implement the function such that whenever we add 6, we add it to the right of the stack, or the top layer of the stack, so that we remove this rather than returning 5. So let's go to the implementation and we will discuss. So first of all, we have stack 1 as an empty list, where we can use a list to implement a replicative stack in Python. We should also keep track of the frequency for each element. So for example, if we add 5, we first add it to the first layer. In this problem example here, we first add 5, and then 7 has frequency of 1, we add it here. Then we have 5 again, but 5 has a frequency of 1 already, so we add it here to the second layer, and so on. So we have 7, and then 4 is added here, and then 5 will add it here. And whenever we for the pop function, we just look what is the top element, which is itself is on a stack. The top element is the more frequent elements in that. So frequency of 2, frequency of 3, frequency of 2, and frequency of 1. So we should find this stack and then pop the rightmost element, or top element in that stack. So for that, we should also keep track of the frequency for each element. So freq is a dictionary, so that for each element in O1, we can simply quickly find the frequency of the element in the dictionary. But for simplicity, I would import from collections, import default dict. So instead, I would use default dict of type in, so that whenever the key is not exist, it should simply return 0. So we don't have to check if the key exists in the stack in the frequency dictionary and then return 0, so it's automatically just return 0. And then for push, first of all we should check what is the frequency of the frec of that element. So now we know that we should return, we should add the element into this stack number, this value. So let me add that first. So we know that whenever we add a new element, the frequency of that is being increased by 1. First of all, let's first add that and then increase the frequency. So this is the level that we should add the element to of the stack. If level, let's add it first, plus equal 1, and then if self dot free equal val greater than the length of self dot stack 1, then self dot stack. That means, for example, for the first time, if we have a 5 element, so the frequency of 5 would be 1 now after this line, but we should add it to layer 0 because Python is 0 based. So if the frequency of that is greater than the length of the stack, so that means the stack doesn't have the list yet. So let's append an empty list, but instead we can, so this is a list, but it should contain a multiple list. So this is would be the stack 1, the secondary stack 1, secondary stack 2, and so on. So if self.frequency is greater than that, so we can simply just add value right there. Otherwise, self.stack1 of self.freq_val -1. For example, in the first time, if the frequency of something is 0, and then you're adding that 1, but it should be added to frequency of a layer of 0 in the first layer stack. So dot append val, and that's it. So in O1, we are adding the elements to our stack. So this push function should take O1. For pop, what are the stack for the most frequent elements? So it would be self dot frec -1. This is the last layer dot pop. So this is value to return, or most frequent is the top element in the last element. And then after that, we already popped that. We should just check if this is an empty list. We pop that as well, so that we know that there are no more elements in that, so that the next time pop is called, the last element is the next one. So for example, 5 had 3 frequencies, and then 2 we had 5 and 4. But as soon as we pop 3, we should remove the whole stack, this layer. All of that should be removed, and then we move back to frequency of 2 as the maximum frequency that we have in our data structure. So if the length of self.frec -1 less than 1, so this is the stack, not frequency. Stack 1, the layer 1 for stack. If the length of stack 1 dot pop, by default it is popping the last element, the top element in the stack, and return most frequent. Also, after that, we should self.freq for most frequent -1, so that we decrease. So here we increase the frequency for that element we are now popping. This take O1 because we are using a dictionary, and with O1 we have access to that. also for this would be O1. So both of these push and pop function would take O1, and relies on the implementation of the list as well, because we are using list. But if we had implemented the linked list, for example, and stored the top element in the stack, it would be faster. But in Python, lists are already well implemented, and I don't have any concern about the speed of that. So that was everything. So we can submit that. We beat 94% of the submissions, and it took about 300 milliseconds. And I also explained I will put a link to the this code, and you can find the code and the detailed explanation for this problem in the description as well. So that was everything for this problem. Hope you enjoyed it.